This is Geometry, Semester 1 Exam Review, Unit 5. For question number 1, we're identifying all the properties of a parallelogram. Well, some special parts. We have two sets of opposite sides parallel. That would be pretty much the definition. Two sets of opposite sides congruent. We have two sets of opposite angles congruent. We have diagonals that bisect each other. Those would be the properties that are specific to a parallelogram. Now I know there's other properties that are special to rectangles or to a rhombus and clearly to a square, but these are ones that would definitely match a parallelogram. Find the values of each variable in the parallelogram. Well, another property we could talk about. Consecutive angles are supplementary. So if consecutive angles are supplementary, we know that 42 plus 2x has to add up to equal 180. Consecutive angles are supplementary because if you have your two parallel lines, these would be called consecutive interior, and we know that those are supplementary. Minus the 42 divided by 2. We have 69. For number 3, to figure out y, we know that opposite angles are congruent, so y is going to be 53. And opposite sides are congruent. So you add the 1 and divide by the 4. In a parallelogram, we know opposite angles are congruent. So we distribute. Subtract the 12. And divide by 4. Just doesn't go in there evenly. Goes in there 3 times, so 30 times and 3/4, or 0.75. Now remember, if you have a parallelogram, well, actually what they're pointing at, we don't have to look at the parallel lines for this. We know diagonals bisect each other is our property. So notice that these two are the same. We know that those two are also going to be the same. So 6x minus 11, 9x minus 53. Bring your smaller x over. That would be at negative 53 actually. add the 53 across. Get 42. Divide by 3. 14. We're going to find the measurements in rhombus ABCD. So a rhombus, some different properties that are a little bit different than a parallelogram. The diagonals are perpendicular to each other. The diagonals bisect opposite angles. So we know that that's 37, and these are 37. We know that if this is 90 degrees, this has to be complementary, or at least add up to 180 total. So that's going to be 53. So that has to be 53 because the diagonal bisects this angle. The diagonals bisect each other, so that's 4 and that's 3. And all the sides in a rhombus are the same, so if this is 5, they're 5 all the way around. So let's see if that helps us now fill in our information here. AE looks like 3 units. AD would be 5 units. Because it's going to be the same as our 5 on that side. EB, well, that's clearly 4. It's already labeled. DB, the whole thing, has to be double that. AB is one of the sides, so that's 5 units. Angle DBA is going to be alternate interior with the 37. That's 37 degrees. DEC is, of course, 90 degrees. ACD, well, these have to add up to 180, so this is 53. CAB is going to be 53 for the same reason this one is. And the perimeter is going to be 5 times 4. Here we have parallelogram LOV is congruent to MATH, love and math. We're going to find the value of X. Well, we're going to look here and notice that angle L corresponds with angle M. Angle H corresponds with angle E. So this is 43. So now we can see that those two angles are not congruent to each other, but they're supplementary. So 2x minus 5 plus 43 have to add up to equal 180. Consecutive interior angles of a parallelogram are supplementary. Let's write that out. Consecutive angles of a parallelogram are supplementary. That might be good to have with your note card. Here we can collect our like terms. So if it's 142 divided by 2, Looks like we're going to get 71. X would be 71. It's not degrees, it's just a value of x. On our next page, we have to decide if the figure is a parallelogram, or is a polygon actually. If it is not, then explain why. If it is, classify it by the number of sides. So a parallelogram has to be made up of segments. That's our key piece there. So here we would have 4 sides. So this is a quadrilateral. This is a curved piece, so not a parallelogram, or not a polygon. Not a parallelogram because of the curve. Because of the curved side. Now this one, it's not our typical polygon. It would actually be called concave because it narrows in like so. We typically have all of ours convex, which means they point outwards, they don't point into the shape. Here we're pointing into the shape, but it still falls underneath the category of a polygon. It's made up of segments. 1, 2, 3, 4, 5, 6 sides. It's a hexagon, and it would be called a concave. Concave polygon. We don't do much with the concaves, but that does fall underneath that category. The perimeter is going to be 48 all the way around. We know that this side is supposed to be 7. This side would have to be 7 also because of a rectangle. Opposite sides are congruent. So both of these are L. So we're going to have 2 L's plus 2 times 7 has to equal 48. So L itself, each length has to be 17. Each width looks like it's 7. A rectangular garden measures 17 meters by 24 meters. So the area, when you calculate area of a rectangular shape, that is length times width. So 17 times 24. So that would be a good calculator question to use. That comes up to 408 meters squared. How much fencing would be needed? Well, think about, where does the fencing go on a rectangle? It goes on the outside. So that would be called the perimeter. So the perimeter, like our previous problem, is 2 times the length plus 2 times the width. That's perimeter. So our perimeter is going to be 2 times 17 plus 2 times 24. So our perimeter is going to be 34 plus 48. That looks like 82 meters. It's not squared because it's a length. It's not area. In the parallelogram ABCD, we have the angle that is 5 times the measure of B. Find the measure of all 4 angles. So A and B, this is a parallelogram. And the way they have it labeled here, A, B, C, D. A is 5 times B. A and B are consecutive, so consecutive angles are supplementary. in a parallelogram. So I'm going to know that A, which is 5 times B, so 5x plus x. If B is x and A is 5 times that, then it is 5 times x. So 6x equals 180. So x, when you divide by 6, 6 goes into 18 3 times and then 0. X has to be 30. So we have two angles that are 30 and two angles that are 150. So the measurement of angle A equals the measurement of angle C, and those are both going to be 150. The measurement of angle B is going to equal the measurement of angle D, and those are both going to be 30. Those are degrees. The vertices of a parallelogram are here. Show that the diagonals are not congruent. Alright, so if we have a parallelogram, there, let's think about this again. We have W here, 2A and 2B be x, 2A plus more and 2B would be y, and then 2C so we have to show that the diagonals are different lengths, so we have to look at the distance formulas. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So in this case, we're going to be looking at xz. xz, you take an x value and an x value, and a y value and a y value. So this becomes 2a minus 2c squared plus 4b squared. And now let's look at what wy would be. W would be 0 minus 2, let's go the other way around just so we don't have to worry about the negatives. 2a plus 2c minus 0, and 2b minus 0. This is going to be 2a plus 2c. 2a plus 2c, and this is 4b squared. So they're very close to the same, but one's minusing from the 2a and one's plusing, so when you're plusing you're going to be longer. So not congruent. xz is not congruent to wy. So next here, we're looking at the midsegment. So you know the midsegment is half the length of AB. So DE equals half of AB. DE is 3x minus 2. AB is 5x plus 1. We could multiply by 2 over here. Distribute. Subtract the 5x. And add the 4. So it gives us x equals 5. In this case, Let's take a look here. Oh, midsegment, right? Midsegment connects with the midpoint. So we know that it divides it in equal pieces. So D is the midpoint of AB. So x equals 7.